Hello everybody, welcome to Linear Optimization using PYOMO. This is a library suggested by Abdel. It's a linear programming library for Python. So in order for you to run it on this machine, you need to do two things. One is you need to do pip install PYOMO, and the next one you have to install the GLP solver. And the GPLP solver is the actual program that does solving of the optimizations. So you can download that from this source here. Okay, put into this folder, okay, and set the path for this folder. Okay, so now let's get started. Like I said before, I'm going to run over the tutorials. And I said to you before that the tutorials are very important. It's a launch pad for being able to do more complicated things. So let's get started. Okay, so we have something called a concrete model. And the concrete model, we have both a concrete and an abstract model. A concrete model means that all the variables are specified. So for example, here we have 2, 3, 3, 4, 1. All these variables are specified, okay? Abstract, these variables are not specified. They're actually specified in a separate file. So let's get started with an example. Okay. So all these files have to be compiled and put into a PY. PY means Python file, because the GLPK optimizer runs on the command prompt. So we need to run this command here in order to get our optimization. So let's start with concrete.py. Okay, so first we import the PYOMO.environ library as PO. So this is the alias. We create a concrete model. As we mentioned before, concrete means the values are there. And then we need to say what x is. So we say x, there's actually two of them. There's x1 and x2. And these are non-negative reals. So they are non-negative reals, which means greater than or equal to 0. We have the objective function, which we label with PO.objective, and we have the expression here. It's 2 times model x1 and 3 times model x2. Next, we have the constraints. So we do model.constraint1 equals to PYOMO constraints. And this is the constraint 3x1 plus 3x2 greater than or equal to 1. Okay. So I can run this here, but it doesn't print out. We actually have to go to the command prompt and type this function here. So let's go there. Okay. Let's type it. Okay. PYOMO solve concrete.py -- solver equal to GLPK -- summary. Let's see. Okay, so we see here, we see that the value of x1 has the value of 0.33, x2 has the value of 0. So there we have it. We have our answers straight there. Now let's go to the next function. Okay, so this is a bit more complicated. It's an abstract example. And an abstract example means that the code, that the expression is not complete. It has variables there that you input the values afterwards, okay? So to run and compile this abstract.py, we need to provide a data file, abstract.dat. And I'll show you what that looks like later on. So here we have a more complicated example. We want to minimize the summation of Cj xj subject to summation of j to n aij xj greater than or equal to bi and xj greater than or equal to 0 for all I is from 1 to m and j 1 to n. Okay, so we're going to specify each one of these variables. Okay, as long as you have this properly written, your optimization code will be fine. Okay, so first we import these two things. It's just how the example was written. I'm not sure exactly what this means, but yeah. Okay, it says right here, to ensure that int or long division arguments are converted to floating point numbers. Okay, so there we go. Okay, so now we're going to use the abstract model, and we're going to specify each of these variables one by one. Okay, so m variable is a parameter that's a non-negative integer. Okay, the n parameter is a non-negative integer. Okay, we can see here they're both integers. Okay, I goes from 1 to m. J goes from 1 to n. A has the subscript I and j. B has the subscript I. C has the subscript j. Okay. Now X has the subscript j, and it's a non-negative real. Okay, these are integers and this is real. Okay, we have an objective expression. Okay, and it's basically a summation of these two values here. Okay, this is a function that's inside the PYOMO, so you need to look it up to see how it works exactly. Then what happens here, so we create the objective function. We send the rule, this summation rule, to the objective function and to the objective object. Okay, we also have a constraint rule, so we sum these a and x for j in m. See, from j to n. Okay, and bi is greater or equal to m right here, m. Okay, and then what we do is that we add the constraint to the model. Okay, this program right here is a data file. So we specify m to be 1, n to be 1. A has the following values, C has the following value, B has the following values. Okay, so that is how you deal with abstract. So let's run the program and we'll see the results. Okay, PYOMO solve abstract.py abstract.dat hyphen solver equals to glpk hyphen summary. Okay, so we got the same result as before. The x1 is 0, and x2 is x1 is 0.3 and x2 is 0. Okay, and yeah. Okay, so that was it. Thank you for staying around and stick around for the next video.